Hey guys, we're going to look at some factoring problems today. And factoring is a big component of the algebra and the algebra 2 regions, so that's why we spend a whole unit working on it. So they put in the center of the page where the box is, like the basic meanings of factor. Okay, so we're going to do factoring. We're going to actually be talking about it as a verb. So it says to rewrite a quantity as an equivalent product. So kind of to show that, let's hop right into some examples. If you look at exercise 1, they want us to factor each of the integers completely. So they want us to basically break them down into only prime numbers. And again, a prime number is a number that is only divisible by 1 in itself. So if I take the number 12, you want to think of factors for 12. Some people use a factor tree. I know I was taught that growing up. And 12 would be 4 times 3. But you could also break down 4 into 2 times 2. So prime factors for 12 would be 2 times 2 times 3. Or sometimes you can write it as 2 squared times 3 because you have 2 2's. If you take a number like 30, you can break 30 into 10 times 3. 3 is prime, and then 10 is not, so 10 will be broken down into 5 times 2. So for 30, we have 5 times 2 times 3. So you can kind of get the idea from those first two examples. Now we're going to look at some where we're dealing with variables, because that's usually what we do in algebra. So we want us to rewrite each of the following as a product of an integer with a different binomial. So what that means basically is that we got to figure out what to factor and what to divide out at each term. And we need to make sure it can go into each term that's given to us in the expression. So like in the case for A, we can divide each of these by 5. And that leaves us with a factored out 5. And then what we have left is just going to be 1x plus 2. So it's pretty similar to like a reverse of the distributive property. Now I'm going to go over to C. For C, 6 and 15. Well, I can't divide 15 by 6. And if you ever get stuck or need to figure it out, you basically just take your calculator and divide the number by whatever you're trying to factor out. You can't do that for the x's. You got to use exponent rules for that. But in the case of this, if I take 15 and try to divide it by 6, I'm going to get a decimal. So I can't do 6 as the greatest common factor for this one. But I can do 3 because I get a whole number out. So I can divide 6x and 15 by 3. And that's going to leave me with a 3 as a factored out apart. And I'm going to have 2x in the parentheses plus 5. Now going on to exercise 3. These are pretty similar, but these all have most of them have a variable that you can factor out. So if you look at B, they do both have an x, and they both can be divisible by 5, so I can divide each of these by 5x. So I have a 5x that gets pulled out, that's my factor. And then I have left after I divide, I have 4 minus x. Because the 5s, the negative 5 and the 5 give you a negative 1. And if you put the 1 there, it's fine, you don't necessarily need to. If you look at C, similar to that, this one again, 10 and 25 you can divide by 5. Okay, and there's x's in both, so I can do 5x. So I have a 5x that got pulled out. I have 2x in my first term, and then I have just 5 because the x's cancel in the second one. Now you can always check these by multiplying them and distributing that number back through, especially if you're not sure if you did it right. But also, like I said, make sure you divide using the calculator if you're not sure if that number is going to be a factor. So it's got to be a factor for all of them. Now we're going to go on to the back of this page. So for exercise 5, they want us to rewrite each of these as a trinomial and a product of whatever we factor out. So like in this case, 2x squared, 8x, and 10. Well, I can divide all these by 2. So 2 is my factor out. Now I would try to do an x, but the 10 doesn't have an x, so I can't take an x out of something that doesn't have it. So I'm left with x squared plus 4x plus 5. That's my remainder in the parentheses. And if you look at C and D, you'll notice that each of those has x's in them. So like for this one here, 8, 12, and 20, I can't divide 12 or 20 by 8, but I can do 4, and they do all have at least one x, so I can take an x out. One thing to be careful with is looking out for signs and what you're dividing by. So like for this right here, we have 2x squared, and it's negative 12 divided by 4, which is negative 3x, and then 20x divided by 4x would be positive 5. So you want to pay close attention to the signs that are there when you divide out, because a lot of times those signs are mistakes. Your products are, when you divide, the two you have is going to really affect what sign you get out. Now if you look at, there is a pattern, sometimes we'll call them conjugates, and sometimes they're referred to as differences of perfect squares. So if each term is a perfect square, it can be broken into those values. So like if you look at A, x squared is a product of x and x, and then negative 9 is a product of negative 3 and positive 3. So this gets into what we talked about in the first unit, when you're multiplying binomials together. And that can be checked by doing that, either the square that we used to do, or you can just do FOIL for it. If you take something like D, again, you're trying to test and see if it's a perfect square. So 16 is a perfect square, it'd be 4. And 4, and then negative 81 and x squared, well, x squared is x times x, and then negative 81 would be negative 9 and positive 9. And again, it is something where you could multiply it out. I could take this, and what happens when you multiply it, I get 16, I get positive 36x. Then when I do the third inside term, I get negative 36x. And then I get negative 9 and positive 9, which would be negative 81x squared. So those two cancel out because they're a positive and negative, and you get back to what we started with. Don't worry so much about fraction ones. If you look at exercise 7b or exercise 7c, let's do 7c right now. 4 and 81 are perfect squares. So I'm going to write that factored part up here. Again, perfect squares, so we'll two sets of parentheses. We'll have 2 over 9 x for each of the first two terms. And then 49 is a perfect square of 7, and 9 is a perfect square of 3. So it'll be minus 7 over 3 and plus 7 over 3. So fractions, the numbers in the fractions, if they're perfect squares, this can be done as well. So that would be your perfect square pair in that case. So as you're working on the questions on the next couple pages, just look for those patterns, and again, if you're not sure, make sure you use your calculator to help you with it. Now the last part we're going to look at is exercise 8, and they're just having us do a combination of the greatest common factor and difference of perfect squares. So what you want to see in any of these cases first is the greatest common factor. So like if you look at D, for example, think to yourself, hey, what can I divide out of each of these terms? So I could divide 3 by 3, and then I could check my calculator. I can also do 48 by 3. And they do both have x's. So I can divide out a 3x. So like in this case, 3x is what I'm dividing, and then I have x squared minus 16 in your parentheses. And that x squared minus 16 happens to be a perfect square. So I can take that 3x, and then I can rewrite the part inside as x minus 4, x plus 4, because 16 is a perfect square of 4 times 4. Also, if you look at like b, well, each of these 7 and 28, I could factor out a 7. So I have 7 outside, and then I have 4x squared minus 1 inside. And then 4 and 1 are perfect squares, so I can write this as 7. And then I can do 2 sets of parentheses. My perfect squares are 2x and 2x, and then I have negative 1 and positive 1. So sometimes we'll talk about completely factored form. And usually when they refer to that on a test, it means you're going to have to do 2 different types of factoring. So let me know if you have any questions, and good luck with this assignment.